My name is Steve. Welcome to my shop. This video I am going to finally tackle a job that I promised almost 2 years ago. As a matter of fact, the first couple of clips that you'll see will be me introducing this S50 Stuart steam engine. I had picked it up in an estate sale, and the steam port was never drilled in it. So I decided that I would dip my toe into the model engineering and take this apart and see if I could get it running. Well, as you'll see as we get into it, I got into a real hornet's nest with this project. But before we start on that, I'd just like to share with you, I have a viewer that has sent me milling cutters on 2 different occasions for my new horizontal mill. His name is Andy, and if you follow Steve Summers, it's the very same Andy that ended up going to Steve Summers and helping him put the roof on the shop. So Andy sent me a couple more items. He sent me it's a number 9 Brown & Sharp taper arbor, and he sent me 2 small shell mills that will fit it, and I believe that it will also fit the shell mill that I have that's got replaceable carbide tips. So it needs a little bit of cleanup, a little TLC, but it's a nice addition to the shop. When I started working on this S50 Stuart steam engine, I had absolutely no information on it whatsoever. And so I began to do what YouTubers do, and I checked YouTube channels that had built S50 steam engines. And I stumbled across the site. Gentleman's name is Andrew Whale, and it's Learning to Turn Metal, I think is the channel name. I will put a link to his channel in my description, and I have actually started binge watching his channel. Very interesting, and I have really enjoyed watching him increase his skills as he's now working on an internal combustion engine after doing 3 steam engines. Well, one of those steam engines, I think the first one that he did was this S50, and included in the description of the video was a list of the drawings for it. So I was able to print out the drawings, and I have a pretty good idea now of how to go about machining this. This video is by no means, it is not a tutorial on how to build an S50 Stuart steam engine. This engine had already been built when I received it, and it had a lot of problems when I started taking it apart, and you'll see them as we go through. So this video is a journey of my reconstruction of an S50 Stuart model steam engine. In Shark Bits 1, I showed you this steam engine that I wanted to start to restore, and what I'm going to do now is open up the valve body and see exactly what's going on there. It was never drilled for the steam ports, and I have no idea whether it was completed, whether the slide valve's in there or not. So here is the unveiling. there it is. The slide valve is intact, although it's not operating because it's slipping on the shaft. This whole thing needs to be taken apart and adjusted. But at least the parts are in there. So now what I have to do is figure out what needs to be drilled and tapped where. This is a Stuart model S50 steam engine. It was built from a casting kit. I did not build it. It was never really finished. The steam ports were not drilled, and so in order to take the cylinder off, I'm going to be taking this thing completely apart. We're going to refurbish it. Since I didn't put it together, I'm kind of flying by the seat of my pants here. There's a set screw in there. The head had broken off of it. Not sure how this went together. It was very dirty. I cleaned it up a little bit before I started taking it apart. Appears to be way out of adjustment also. The other thing I have observed, I watched some videos on the actually making this, and this valve body appears to have been put on backwards or upside down. So we'll see about that. The cover for it was never drilled for the steam inlet, and to the best of my knowledge, the cylinder was never drilled for the steam exhaust, and it doesn't look like the steam ports were ever drilled from the end into the body. So I'm going to completely disassemble it and see where it goes. I was able to find some drawings for it, and I printed out the couple that I thought I needed, but it looks like I might need some more information. Especially if I have to drill those steam ports, I'm going to have to get the correct dimensions on them. It was awful tight, so I'm going to check the dimensions. And the cylinder assembly is actually loose on the base. So let's see what's going on here. It appears as though all they did was just put this together for appearance sake. The cover was never put onto the cylinder. So it started out as me thinking I could just drill a couple of steam port holes is looking a lot more complicated. There's a screw missing out of the mount on this. From the looks of everything else, it probably didn't fit, so they didn't put it in there. Probably wasn't aligned correctly. I don't know whether you can see this or not. Let me see if I can zoom in on it. The mounting hole on the top missed. It was never completely drilled. That one's awful close to the edge. The whole thing looks like it was shifted over. So I've got a mess to fix up. I think I'll probably braze that up, mill it off, and then re-drill it. Well, I'll finish taking that out off camera, and I'm going to pull the cylinder heads off, and I'll bring you back when I get them off. Okay, there's no packing on the gland nut, and the steam ports were never drilled. And that's going to be a little bit of a problem, because the mounting holes for the cylinder head this is right in line with where the steam port needs to be drilled. This side's okay, but this side is a problem. So what I thought was going to be a simple little job of drilling and tapping a couple of holes for some fittings has turned out to be quite another project. I don't think that's even square. Not even close. It was not squared up when it was machined. Actually, the bottom was never machined flat, which is not a, well, not a huge deal, but the valve body should be square to it. It does look like I've got enough meat that I can square it up. Okay, we'll come back later. Hey, the first thing I did was take the base over to the surface plate, and the bottom was not flat, so I just hit it on the belt sander and got it so there's no rock in it on the surface plate. The other thing I checked was that the height of these rails were correct for the center line of the crankshaft, and that also appears to be correct, but the machining is quite rough on it, and the block does not slide nicely on there. So I'm going to just, I hit it with a stone first, but it needs a little bit more than that. That's good. Now I'm going to use my precision ground flat stones on it just to improve the finish some. I'm going to do a little bit more work on that. It's developing almost like a mirror finish on it. And I've got to check this block. This doesn't appear to have been machined square at all. In fact, it's got extra hole in it. I may end up remaking that out of a piece of brass stock. Alright, we'll come back when I'm ready to go to the next step. On further inspection on this hole that appeared to be out of position, there's a broken tap in there. Got to deal with that now. Okay, this near edge is actually at about the right dimension, but there's quite a steep angle between here, and this rear edge is raised quite a bit. So I'm going to take some light cuts until I just dust that edge off, because that seems to be correct. So let's see how this works. The worst thing that'll happen is that I have to get a new casting. It's pretty even along there, so it's in the vice square. I was a little concerned about that. I'm going to take 10,000ths at a time off here. Just about there. I'm going to take another 5,000ths off. Check it out. Well, that picked up the whole surface. Let's see how I made out. Seems to me that I haven't taken enough material off to make it square, but it wasn't out as far as I thought. It's somewhat of an optical illusion, actually, as this is square now, and this edge is square. But the corner of this has been knocked off, and that's making the illusion that it's way out of square, but it's really not. So we're pretty good there. My next repair is to try and remove the broken tap that's in here. It's in this hole here. I'm going to see if I can, there we go. You can see that it's already, apparently somebody has tried to work on it, and they've opened up the side. So I'm going to go after that tap. I'll take you over to the milling machine and show you what I'm going to do. Okay, I've got a solid carbide end mill in there, and I've got the depth stop set. Now what I'm going to do is nibble my way in from the side up to the tap, and I'm going to try and pick the tap out of there. After I have that done, I'm going to silver solder a plug in there so that I can remachine the piece and rethread it. So let's see if this works. If it doesn't work, you're never going to see it. Just taking 5,000ths at a time. At some point, I should hear it hit the tap, hoping that just a high-speed steel or carbon steel tap, and the carbide should nibble away at it. Just starting to get into it now. I'm going to slow my feed down. A few thousandths at a time. There's the tap, you can hear it. Let's see if I can pick it out of there now. I've got some more of it, I'm almost there. It looks like it might be a little, I can check the depth of the other holes. And that's how I set my depth. I think I got to go a little deeper. As it looks like it's going down beyond where I have machined. It's almost gone. I am cutting it. Shoot. A little too aggressive. I broke the mill. But it took the piece of tap out of there, so that's what happened. The piece of tap came out and jammed and broke the mill. Oh well. Nothing ventured, nothing gained. So now all I'm going to do is take a I've got some other high-speed mills the same size, and I can go in there with the high-speed mill and just clean that up a little bit and get it ready to silver solder. So I've got it all cleaned out, the tap all cleaned out, and so now I will fit a piece of brass in there and silver solder it. But that'll have to wait for part 2. Well, that's going to wrap up this part 1 of the S50 Stuart steam engine rebuild. I got very lucky. After breaking that carbide tap, I have a tendency to buy everything in multiples, and I had another one. I had a replacement for it, fortunately, and you just saw the results of that. So in part 2, I will be silver soldering a plug into the area where I just took out the broken tap, and then we'll go ahead and machine the cylinder casting and re-drill it. And then the next problem is that the steam ports were never drilled. So I'll be drilling the steam ports and getting it ready to put back together. So I'll see you in the next video.